Um, Hello, good evening, everybody. This is Sumit here. So it's exactly 4 p.m. and let's just give about 2-3 minutes that people can join us. And this is like the session, we can say number 3 in a series of sessions on moving from monolithic to microservices. So we have already had 2 sessions. For those of you who might have not attended those, you can just take a look at the chat box. Okay, when you have the time after the session, or whenever you have the time, just go back and click on those presentations and the links provided there. Okay, and yeah, so that's the idea. The current screen that is shown is about my book. People who already attended my training, they know that I have a recently published book, and if anybody is interested to buy that, they can just use that QR code, scan that, use that code there, which is given on the top right, and buy the book. Okay, that's about primarily about Microsoft's decision making. Okay, so let's just give 2 to 3 minutes and let's see how many people join. The first session we had 75, second session we had 125. So let's just give 2 minutes. Um, yeah. All right, guys. So I was telling you uh, that we had 2 sessions of this XKE series, and this is the session number 3 in the same series. The session number 1 was the pains of monolithic architecture, and it covered an in-depth introduction to monolithic, the failures, disadvantages, pitfalls of monolithic. We had a brief introduction to microservices, and the session 2 was related to um, the needs and motivations for microservices. Here we covered the promise of microservice architecture, the shortcomings of monolithic, the needs and motivations by itself, and challenges of adopting microservices, and the state of microservice adoption in 2021. So these topics are over, okay, in this series. And here we are today for session number 3, which is moving from monolithic to microservices. Here we try to identify uh, and understand existing monolithic architecture, understand and identify the services that the services that are candidates to move from monolithic to microservices. Briefly touch upon challenges because that we already covered. So we'll very briefly touch upon that, and then what are the ways ways of certifying or kind of making sure that your architectural microservice is ready, and then we'll just very briefly talk about the reference implementation of the microservice architecture that we talked through in this series of microservice sessions. Okay, so that is the idea. Okay, that's the agenda. Um, so we have 100 people right now on this session. Okay, so the mode will be that because there is enough and there is less time and there is enough kind of, you can say, topics. So what I'll do is we'll have 2 breakout kind of sessions. You people can collate your queries. Basically, it's a open discussion, okay? But I can't make it more interactive because of time constraints. So what we'll do is, what are queries you collate? At the end of about 25 minutes, we'll have one 5-minute session, and then we'll just quickly go through all the kind of. We'll open the forum, and everybody can kind of share their thoughts and queries. And the same thing we'll do at about 4:55 p.m., like 5 minutes each. Okay, so that's the idea. That's the mode. So just hold on to your queries, and then take it. You can just your queries, your thoughts, all of them. You can kind of use those breakout sessions to add value to this session. Okay, that's the idea. Okay, so for all of you who are attending this for the first time, I'm sure whatever career phase you are in, whether it's the early, whether it's mid level, or it's senior level, all of you have come across these words at least: monolithic, microservice SOA, and serverless. And I'm sure at this point in time, many of you are working on microservice architecture in whatever implementation stack, whether it's Java, J2E, C Sharp. You're working in one form of cloud or container or the other. At the same time, there will be many people working on SOA, and there will be many people working on monolithic, and there will be few on serverless as well. So most of you would have been part of the journey where maybe you worked on at least one project which had moved from monolithic to microservices, or at least in this your career journey, you would have worked on monolithic to microservices in some way or the other. So I will not cover much on this points because these are already covered in the previous sessions. Okay, so monolithic architecture, even in today's relevance, even if we talk about today's world, it is ideal for startups and small applications with small resource bases. We would still want to say that if there are less scalability constraints, or the code base is suppose is going to be small, there are less functional points, and it's like a small startup or small application, we can still consider to use monolithic architecture. There's nothing wrong in that, or there's no loss or no kind of you can say degradation of performance or scalability that may happen by choosing monolithic. Okay, at the same time, for complex large-scale systems, most enterprise software architecture will fall into complex large-scale systems, and we will have multiple skill teams that are across the globe. It will require coordination between multiple teams across the world, possibly multiple skills as will be involved as well. So under these circumstances, microservices become the right candidate. Okay, the other two I'm not going to talk about in this, at least for now. Okay, so for all of you who are starting for the first time in this series, in this session, so what is monolithic software architecture? Okay, I'll just very quickly read out. It's a very virtual single block of components to serve all the application requests. Okay, it's one of the forms that has existed ever since software development and software engineering came into the world. It may be distributed or non-distributed application. Usually in a monolith, the implementation consists of various layers to achieve the functionalities as per the application requirements. Even though it may have few asynchronous components of functionalities, for all purposes, you can imagine it to be a monolithic block or centralized block consisting of various layers to achieve the end goal. Few types of monolithic architecture are two-tier, three-tier, or in-tier applications. Now, what it simply means is that, like you might have worked on architectures which are having like a web layer, a business layer, database layer. You might have worked on desktop-based applications. Possibly you worked on things which are just having a business layer and a database layer. So whatever it is, all of these in a traditional orthodox form, they are all monolithic architectures. They might be distributed, they might be not distributed, but all of them were a monolith, as the word suggests, a single block of application to serve all application requests or to serve the customers or the users. That's the idea of having monolithic software architecture. In its more, in its most basic form, this is the idea of monolithic software architecture. So Microsoft's architecture, it's primarily about um, whatever we had in monolithic. It was set of services. Now with microservices, we try to okay. Let me just first read out the state of the art and has caught on to almost all enterprises and every medium to large software development project, Microsoft's architecture. The core thought involves troops, decentralization of services or application, and more fine-grained splitting or division of application services into individual services of their own. Also, MSA brings in newer and complex form of infrastructure services to aid in the real ownership of respective infrastructure responsibility. Though it has its own set of disadvantages, it allows for independent scaling and selling of services to a customer or any external stakeholder. So what this means is that every business application has many use cases, has many services. Components might not be the right way to define, but many services. Components is also okay to say the components. So all of them might have their own scalability, performance, and their own needs in terms of CPU power, in terms of memory required, in terms of number of users going to use them, the time that's going to be used for, and its complexity that it involves. Under all such circumstances, we we would want to split those services or components into kind of servers of their own, or into a monolith, or into a microservice of its own. So when it becomes very specific to a service, it becomes the microservice architecture. So you think of monolith as services and microservice as set of services coordinating to give the functionality. And monolith is a set of services across one monolith to satisfy the user customer request. That's the idea. Okay. Okay. So in this session, what we're going to do is we're going to provide a sequence of steps. Okay. It's just going to be a guideline reference for architect or technical stakeholders to decide on the strategy, how they're going to plan out their movement from microservice to monolith to microservices. So there are many of you who might be at, you can say, starting levels, but at least you can, for you it might be at least like you can say first dive into the world of what is monolithic, what is microservices. For people who are mid-level, senior level, they might be part of this various times. Okay, especially senior level folks, they'll be part of this strategy planning multiple times. So for them, is a special kind of, you can say, they can use this as a reference session and kind of hopefully collect points which will be useful for their real work. Okay, for other people as well, at least they have the correct understanding to get ahead in their day-to-day work. Okay, so the session will also help you give you the insights so that you can get a no decision for microservices. And so if you will also be provided a guideline like how you can certify or you can get microservice readiness so that your company or your customers who are you're working for can decide whether to go ahead with the microservice architecture or not. Okay, or we can stick to some hybrid variety or some provide some in-place solutions. So that's the idea of having. That is the possible the top takeaways from this session, which you should have. Okay. So what is the um, uh, okay? So I already mentioned the most common architecture that has ever been in existence is the monolithic form of software architecture ever since the advent of software development, software engineering. Okay. Um, okay. So first of all, the first important step that involves movement from monolithic to microservices that the architect or the stakeholder. Okay, why say architect? Because usually this task is given to very senior level engineers. Okay, who are architects or senior architects, that they identify what is there in the current monolithic architecture. Okay, it will be just as simple as understanding what is the in totality what are the components that exist right now in a monolith, what are the services that are being provided. Okay, so and you should have a knowledge to some extent of the all kinds of product configuration which are being used within the product, and all of these things. Basically, anything that is to do with technical architecture, configuration, code, all of that you should have a good understanding. So that is where you begin a journey to move from monolith to microservices. Okay. Now, the various contexts. How do you understand? Like you say that I understood the existing monolithic architecture by knowing what are the core functionalities and the core features, what are the non-core features or supporting features for the product, what are the major issues faced by the application. Okay, that is one very important point. What are the performance reports in terms of load and stress test? What is the database design? You need to know the database design very correctly. Okay, you need to identify the business entities and objects. Okay, what are the additional resources in the ecosystem, whether in messaging frameworks, whether it's a file system usage. Okay, what is the vision of the management for the future? So what is the vision that the management has got for the future? So what all of these points, like number 1 to 7, are mostly technical in nature. Number 8 is about which is the direction that the company is moving towards. They want to sell their service independently. They want less time for new service to be developed. So those kind of things is usually the vision of the management for the future. So this is the kind of points that you note down to say that I understand the existing product correctly. I understand the existing monolithic architecture correctly. Okay. Only if you have this knowledge to a decent enough extent, will you be able to make the right decisions. Okay. So the idea is to enable you to make the right decisions when you move from a monolithic software architecture to microservices. Okay. Okay. So let's start with the first identification that all right. So we have 101 people right now in the session. All right. Okay. So the number one point, okay, when I say when you have to identify in your current existing monolithic architecture, it will be the core features in terms of scalability. Okay. The stakeholder first needs to identify the core features that be candidate for scalability. Okay, the success of the business entirely depends on the success of its core features primarily. Like let's say business, it means business and product are used interchangeably because most of the product companies, the product is their business. Okay, so this becomes one of the candidate in the business context as well, which means that knowing the knowing the core features, their scalability requirements, the usage by the current customers, okay, and understanding that they are not they are suffering from some kind of scalability issues, or they can be more scalable. Okay, so because in earlier monolithic architectures, if we talk of scalability, we talk of the entire set of services. Here we say that we understand the components or services by itself, and we understand its usage. It's you can say the volume of usage, and then we understand how we can scale them independently. So the features which require the core features which require you can say greater scalability requirements. So those will become candidates to move from monolithic service to microservices. Okay, why you have the answer? You know it because when I talk this, you visualize this in your mind, all of you. Like whatever you are working on, just think. When I say when Sumit is saying core feature scalability, what it means? It means that in my product, I'm working on some X feature. It is called as something called as credit payment. It is called as create schedule. Okay, it's called as create employee timetable or anything of that sort. Okay, it might be even search services. It might be even something information security service. So whatever it is, you have to in your mind you have to visualize that when I'm going to scale monolithic, we talk about things which are like symmetric scalability, that every service has their own, has the same scalability requirement, which is not true. Okay. So those features which require have greater scalability requirements, which are mostly core features, they have to be removed and moved from monolith to microservices. Okay. Stability. Now, sometimes what may happen is that some features might have stability issues. Okay. This might be because they are talking to external databases, external, which is not within the current. Okay, due to some reason, they have to talk to some other service. They're talking to external messaging services, file systems. They're talking to some. They're waiting for some external events. They are waiting for streaming data. They or there are some external components which are within your realm only in terms of deployment. They have some poor programming, poor design, memory leaks which you cannot fix, but you can deploy. So under such circumstances, you might think of using. You might think of moving those features because stability requirements. You want to move them from monolith to microservices. This is not a, in this case, we cannot say that it's a solution, but it's for the, in the given context, this is the right way to do it, that we move it from monolith to microservices, okay? Because there might be times that they're unstable or unresponsive. So microservice allows that because sometimes if like what happens in monolith, if the entire, if one service is down, almost all of the time, everything goes down. So it starts saying the system is unavailable, okay? But in microservices, there's elegance. If part of the system is down, we can only say that sorry, we are not able to serve you right now for this feature. Okay, but other parts of the system will be available for you. So that's the idea of having. That's the idea of this point: core feature stability. For core features, there might where stability requirements. It is unstable or it is prone to some external kind of, you can say, instability due to external dependency. Under such circumstance, we might consider them to move to microservice architecture. Performance requirements. Okay, when we talk of scalability, we talk of the whole, and when we talk of performance, it means a single, which means that one particular API in a single request, the response which we fetch, that is a performance. Now, what it means is that sometimes during for increased loads, there might be logic intensive or API logic intensive features. So under the circumstance, there might be strict need that we try to move them to independent server, have its own independent CPU, independent RAM. So these kind of features, or there might be components, there might be some back processing units. So they might all merit their own microservice. So that is one candidate to say that we'll move from monolith to microservices. Okay, independent scaling. Okay, now we talked about core features, stability, core feature scaling. Now there is you have to think from a different perspective now. Independent scaling. There is a course. There is not a. It's not. We don't have core feature, but we have service which is which requires independent scaling under certain circumstances, or under certain dates, or under certain regions. They have their own independent scaling requirements. Whenever such kind of features, okay, when such kind of asynchronous or back process exists, then we can think of moving them from monolith to microservices. Okay, these points which are telling you the headings, they're primarily meant to identify in your existing monolithic architecture. If they fall into any of these brackets, they become the candidate. They can go and say to your team or to you, who is the primary stakeholders, you can present them saying that they fall under these. You can draw a matrix. Okay, they're saying that one heading, core features, scalability, stability, performance, and independent scaling. Then you can write down your services under them, saying that they fall under these categories. That is why they are a candidate to move from monolith to microservices. So that is the usual debate that starts in an organization or in a team. Why should I move to microservices? What is the reason? Okay. So that is under these lines of thought is where you're going to start thinking whether you have to move a feature from monolith to microservices. Okay. Now, independent maintenance. What this means is that sometimes regions, for people who have worked on large projects where there are coordination among, let's say, teams between India, UK, US, Malaysia, China, and we don't know what. There are many countries that are involved for a project many times. So what happens is that the maintenance of parts of application might be concerned sometimes in terms of skill, in terms of possibly very rare it happens, but in terms of domain, just because that particular feature is built for that particular region, so the maintenance might be offloaded back to that nation. So that kind of under such circumstances, if they require some independent maintenance by specific teams or in a specific region or by some specialist groups, under such circumstance, which you visualize such when you visualize such kind of business requirements, then it becomes a candidate to move from monolith to microservices. So it can be independently dealt with. Okay, independent development is something which I'm sure all of you know. What it means is that whenever you're working on greenfield or scratch development, like when you're working on a fresh development project, okay, it's the previous point and this point are correlated. Only thing that here we talk only of technology. Okay. Um, uh, when you're working on geographically disparate environments, let's say we are going to work on Java J2E in Bangalore, and the Python team sits in the US, and somehow we have some kind of support team that sits in the UK. Now, support means they just do bug fixing kind of thing, and they support a legacy C# project, but they are all correlated. Now, whenever we have such kind of requirements and development has to happen across all three areas, okay, even in the support teams, some development is going on. I mean, they have some kind of specific patch development. So under such circumstance, you might think that this is an independent development, and it is let the specific geographic teams based on technical skill, domain competencies, take decisions in their own region, in their own environment, because it might be faster cycle times. Under such circumstance, we can consider them as a candidate to move from monolith to microservices. Okay, so these points, okay, I am not saying this entirety is covered, but these are the like most important points which I can tell you: core features, scalability, stability, performance requirements, independent scaling, independent maintenance, independent development. When you want to decide in a project why you need to move to microservices, usually almost always it may fall under these, or directly or indirectly will fall under these headings, and that is the reason why you want to move from monolith to microservices. Okay, so that's a kind of idea of moving from monolith to microservices. Okay, at this juncture, let me just quickly see what's um, one moment. Okay, I want to open the forum for everybody to participate. Okay, basically you can share your thoughts on monolith to microservices. You can present your queries or thoughts or anything. Okay, I want you people to take up the forum. It's not necessarily queries. It might just something you want to share and which will be useful for this group. Okay, anything to do with microservices, monolith, clouds, containers, something innovative. I would just want you people to go ahead and use the next 5 minutes. And before we come back to the next slide, yes, guys, time to unmute and take ahead. You can just share maybe whatever I told you just now is what you are doing currently in your current project. It might be for any customer. If you want to share that this was a real world thing which happened, it will be very useful for the other people who are there here, even for me. So if you want to go ahead, share such things or queries itself, or yeah, or you want to add something more to this discussion, please go ahead. Hello guys, are you awake? At least yes, say yes.
Yes, sir.
Okay, okay, okay. Yeah, somebody raised a hand. Ingit, no. Okay.
Yeah, I was just saying that I am awake.
Okay, yeah, good. Okay, yeah, guys. If not, then I'll have to move ahead. Shall I?
Sumit, we are going through this.
Sorry. Sorry, somebody said something I couldn't hear.
Yeah, it's Deepak. I'm saying I'm going through this.
Sorry, Deepak, your voice is breaking. Hello, Deepak.
Hello, am I audible?
Yeah, please go ahead. Yeah.
Yeah, I was saying that I was going through this.
Okay. All right, guys. So can I proceed?
Yes, Sumit.
Okay. All right. So now in this story, we have reached to a point where uh, you let's say the primary, let's say architect or the primary technical stakeholder deciding the movement has now, you can say, he has to work parallelly. One, he has to get ahead with this process of identifying the services which require move from monolith to microservices. The same time, he has to make sure that he has gained enough knowledge on microservice architecture. So see, actually, it's no rocket science, but it's a just, you can say, you cannot say the simple use of Spring Boot is microservices. But yes, the simple use of Spring Boot, it enables you to use microservices very easily. Okay. Now that's the idea. So what I'm trying to tell you in this statement is that you have to keep gaining on the microservice architecture front in terms of understanding the entire, you can say, infrastructure, the kind of issues that you'll face in terms of whether it is simply scalability, whether in terms of messaging, event driven architectures, in terms of databases. So, what are the kind of issues that you'll face can come only when you start understanding microservices better. Okay. And at the same time, parallel thread is that where I told you these 6 points. You bracket your existing product into those six headings. Okay. All right. So first thing is literature survey. Now, literature survey is something like a very scientific word. What it means is that try to collect as much knowledge about, okay, possibly even this presentation, just collect as much standardized architecture diagrams, design patterns, reference implementations, online books and blueprints. I mean, it's not to become like the like spend your entire effort on this, but whatever is relevant for you in that time frame, to collect as much as knowledge, okay, on the subject matter, which is Microsoft architecture. Okay, what it means is that there are some standardized sites which say that this is a standardized architecture. One of them is Microservices.io. Then there is even IBM standard blueprint is there. Microsoft's blueprint is there. So on all these things will give you that knowledge of what is the standardized Microservice architecture look like in a enterprise. So based upon all of these things, okay, and understand the design patterns which are there, microservices, okay, and then only you can come up with your specific Microsoft strategy for your enterprise or for your product. Okay. Okay. Case studies. Now, this is one very important thing. There are so for like let's say a company as big as, for an example, JP Morgan or Morgan Stanley. They were on Monolithic. The first time they're going to move microservices. And they won't decide firsthand, like beforehand, before they start moving microservices, what are the kind of things that other people face in the, because it's a very big organization, they might have many projects. I'm just giving a just an example. There might be other big companies as well. So under those circumstances, it's better to identify, because you have to learn from others mistakes, okay, not make the mistake yourself. So it gives a great advantage to the company and to the architect that they identify what are those pitfalls, failures and shortcomings before they decide to move from monolith to microservices. So case studies is the second point. The next point is, okay, like I already mentioned, understanding microservices. Just the simple task of doing the, here the point of literature survey, here's understanding microservices, okay. That is specifically doing some simple kind of, even before POC, you understand the specific frameworks that you want to use. You understand the kind of advantages, okay. Just like you understood the disadvantages and pain points here, the case studies. These 2 points are related. Only thing is that here we start moving to the world where we understand the advantage itself and try to optimize it for our usage. Okay. And the applicability. Applicability means what is the real reason why I want to use Microsoft in an organization. Okay. Understanding of Microsoft is one thing, which is the depth. Applicability is just the, you can say, surface. Why I need it? Why? What is the reason that I want to move from one type of architecture to another type of architecture? I am, if I'm not getting anything at the end and I end up with some performance issues at the, why do I want to go for microservices? Okay. So that's the idea, applicability. Okay, the next reason is design. The next point is design patterns. Okay, one very important thing that you have to like people have to understand who are senior technical level professionals, that many a times like the failure. Okay, when I say failure, it means that other than maintenance hell, sometimes database or let's say design patterns around messaging, API, any API usage, security, the creation of microservices, how we are going to creation means like how we are going to distribute the work across the teams. So all these kind of um, uh, things lead to very, very great issues. Okay. So some of them are described very well in terms of design patterns. Okay. Like you might have heard of the words like event sourcing, CQRS, Saga. Okay. All these are design patterns in microservices. If you're not heard, I'm just giving you some terms. These are like design patterns which exist to handle data management issues. Okay. So beforehand, it's better to identify what design patterns will be applicable for you. And then the next one is reference implementation. Okay. Now, once like we have spent enough time, like let's say we have spent some time to kind of understand applicability. We have done some deep dive of microservices. We have literature survey, case studies. We have to go and implement our reference implementation. Okay, before we get into the like we would have gone through theory, the philosophy, pragmatism of adopting microservices. The time comes to do what all of us do best, which is the coming up with the simple reference implementation. Okay, that is coding, development, programming, engineering, the reference implementation or the basic prototype or POC. So that reference implementation can act as the you can say as the driver for all the activities. Okay, because whenever a company is doing some research activity, putting effort to research, we usually come out with some kind of reference implementation that becomes the you can say the central thought process where we look upon for all our things to iron out. Like when we have any issues, performance, stability, scalability, understanding, newer frameworks. So we iron them out at the reference implementation level, at the POC prototype level, and then take it to you can say production line or take it ahead to development of the actual product. So that's the idea. Okay. So in our case, like we have gone through these three sessions, and most of it we are covering lot of things around the entirety of the microservices, the philosophy, pragmatism, the issues, the concerns, the advantages, challenges. So in the session number five, this is session number three, five, I'll be taking you through hands-on, step by step to creating the microservice infrastructure. Okay. The next session we'll actually try to cover the coding, branching strategies, what are the planning we have to do for agile and all that. But fifth session will be to do the actual obliques is the name of the reference implementation that we are building, and we will be kind of taking you. I'll take you through the. It's like a simple, you can say, workshop or hands-on activity that we do. I'll try to take you through building a complete microservice infrastructure using Java, Spring Boot, J2E, and those kind of areas, MySQL, and all that. Okay. So yeah, that's the idea of how first one is identifying, and the next one was the research, like how to make sure we have. So the two threads that we have, one is the task of identifying, another is the task of gaining knowledge. Both are very important for any company, any architect, any primary technical stakeholder to decide on whether we are ready for microservices, whether we need microservices, and whether we are going to do microservices, whether we are going to do microservices the right way, and whether we are doing microservices the right way. Both are different things. Okay, we have to make sure first in thought and then in what actually we are doing. So both have to be very robust before we kind of just get into the idea of saying that organization is start to we are like using Microsoft architecture. Okay, even though Microsoft is very popular now, still there is a very big curve that many companies are still moving towards microservices for their existing products, to newer products. There are still companies who are taking up Microsoft projects for the first time. That is a kind of thing which is happening. Okay, it's usually called under application modernization, which many companies are doing. Many customers they'll have something called as application modernization, and they'll be taking it Microsoft strategy. There will be big names there, medium names, small names, and all of them are now right now moving to micro services. Okay, so let's talk about Microsoft readiness and certification. Okay, now whatever I spoke just now, in the end, how to verify that we are ready and we are certified for microservice. Okay, now it should not be that simply because other people are using microservices, we are using microservices. We ensured that uh, we need microservices. Okay, we want to use microservices because of so and so reason under those 6 points, and we have enough knowledge. So once the architecture has been laid out, we need to make sure that it is certified as meeting the needs of the organization. Okay, and it is not necessary that we meet all the standard components, all the guidelines, but whatever is required, it can be sustained by the organization, it can be sustained by the organization, and the product can sustain business. Like we can, whatever business is, it is within those realms of reality that we are proposing the software architecture for microservices. Okay, that's the idea. Okay, now how we can do this readiness survey and test, applicability survey and test. Okay, there is some sites. Okay, most of the times when we have to take up newer things in organization, companies form internal review committees, which contains senior technical resources, lead engineers. There might be senior management folks as well, and then they prepare some surveys, test checklists, and say that these are the things that we have to meet. And then we propose to senior management, or we propose to the final decision making, the budgetary council or the organized whatever budgetary council we have, who allocates the budget, who allocates the projects, or who says that one is technical aspects, one is the budgetary concern, everything that we lay out, and we say that yes, we are ready to adopt microservices, and this is the way to adopt microservices. Okay, and there are other external. That is one way of doing the things. Okay, other ways that we might hire external specialists who can do this activities for us. We come out with everything, and the external expert consultants, they kind of review and say that yes, this is fine, and because they might be experts in those areas. Okay, in terms of readiness certification and catching issues early. And then they say that yes, it's certified by me, by us, that you're fine to get ahead with microservice architecture. Okay. Or there are some online resources as well. One link is shown in the screen. So they allow us to go and we have to answer a few questions there. We have to kind of make sure that we answer it correctly. People who are knowledgeable have to go and do that for your product, and then we can say whether the our product is ready for microservices and is certified to be following standard architecture. So that is the idea. Okay, either internal stakeholders, external stakeholders, and in combination, you can use these online surveys or online resources to make sure that your microservice is ready and certified. Okay, so that is the kind of uh, one moment. Yeah. So this particular thing here. Okay. Um, so the whatever that I mentioned, three sessions. Okay, they were like I told you, monolithic architecture, and here we are taking at the at the end of this, we have to actually come up with the reference implementation. So my reference implementation is called as obliques. Okay, this is the it's how I visualize microservices architecture in its entirety. It's like a big fat animal. So I came up with this word obliques. Okay. Yeah. So that image is not copyrighted. I've taken it from the internet. So the idea is that we'll be building this. I'll be taking you through some aspects of it in the future XK sessions. How we are going to build this reference implementation. So what it will contain? It will contain things like it will be on Java J2E, and whatever we discussed, we'll whatever we discuss in this three sessions, four sessions, we'll have one more session after this. So in that, whatever we discuss, we'll try to see in the code, in the way it's working, whether we are answering those questions or not. Okay. So we'll have API gateway, we'll have things like circuit breakers, service discovery, config server, we'll have load balancing strategies, config server bus refreshes, messaging, design patterns, service mesh we might try to cover, Docker we might try to cover, security, sessions, tokens, data access, Kubernetes we might try to cover, Maven, GitHub, AWS obviously will be there, logging, auditing, log analysis. So what are we discussed in this entire, like we say, like I told you again and again, whether you call it theory, the philosophy, pragmatism, the understanding, the basis, whether when we are building them, whether we are going to answer the questions in the code, whether in that architecture the answers are there, and when we compare them to the previous monolithic architecture, whether we can get, whether all of us are able to get those answers. Okay, yes. So this is how why it's so elegant, why it's so easy for me. Yes, it can independently scale. Yes, this is like a independent. We can independently sell this. It's very easier development cycle. I can visualize that if it's being built across the world, it'll be much easier. So all of those things you yourself will have to answer when we do this development. Okay, and talk of standardizations, whatever talk we had in terms of readiness certification, all those things, whether we can answer or not. Okay, so like I said, like I'm mentioning here, I always consider Microsoft's mammoth effort, and it makes many of the ongoing enterprise needs easy. So I'm remembering one of my favorite cartoon character. It's Oblix. That's why I named the representation Oblix. Okay. In the session number 5, we'll do it hands-on. At least in one session, we'll try to cover most parts of the implementation. Okay. Okay, so in this there is whatever we discussed right now. Okay, there is one topic which I had covered in the previous session. It's called as the challenges of moving to microservices. Okay, so I'm just trying to bring that up. I want to cover that once. Till now, we discussed about moving from monolith to microservices. What are the challenges? I just want to quickly try to cover that for 5 minutes. What are the challenges that we face? Okay, just give me 1 minute. Um, um, okay, just give me one moment. Um, just trying to pull it out. Okay, just 1 minute. Okay, I'm just trying to um, open a different presentation. Okay, yeah. So just let me. Uh, so guys, can you see my screen?
Yes, ma'am.
Everybody can see my screen?
Yes.
Okay. So challenges are that. So whenever we are having any microservice adoption, okay. First of all, we spoke about how to move from monolith to microservices. I had covered this in the last session very briefly. I'll touch upon again because very important. Remember that it's not so easy again just to go ahead and adopt it. Once you have said yes, 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 what are the challenges? We have overhead. Okay, overhead means that we now need to include many standard components. Okay, in terms of DevOps, in terms of you can say system enablement, how we are going to incorporate those. That's the overhead that is involved. High skill, okay? So even though this seems like a very kind of term on the paper, but it's true. With microservices, we require more highly skilled developers than usual monolithic forms. They require a newer understanding of the system, what is going to happen in terms of data management, in terms of messaging, event-driven architecture. There are many, many things to take care of. So that is where the higher skill of the developers is required. And then uh, we can talk of complexity because now we have many, many more services. It's not just the infrastructure level, at the business use case level, at the point where need to maintain code, we have more complexity. Okay. At the same time, there can be redundancy. So redundancy means that the code which is there on one system. Okay. So you understand when we are going to have, let's say, a credit credit a credit payer use case, and we have debit payer. Now, many of the things which we are going to use in terms of security, logging, or in terms of utilities, they can be used commonly across. Okay, but what happens? People might know them, like who have worked on microservices. That many a times redundancy happens. Code gets duplicated across in terms of code, in terms of understanding, in terms of functionalities. Many times things get duplicated across two particular components because they're being developed separately. Nobody has idea of what is happening going on inside. So not just the redundancy in terms of code, but in terms of functionality. People end up developing simple features again and again. Okay, so that don't repeat yourself. Keep it simple, stupid. These are all clean code principles. Okay, so we have to make sure that we follow. You ain't gonna need it. You might have heard of these things in clean code principles. We have to make sure that we follow them. Data duplication. Now, this is one great challenge. Okay, I'll help you visualize this problem. What happens is that, let's say, when you are having let's say a product, okay, and then you have product is one microservice. Product management means product management is inventory management, like products. Then you have purchase kind of management. So what happens is that these are different microservices. They are all dealing with the selling and purchase of products. Now, whenever product is added to a system, they get added via the purchase system. The sales make sure that when somebody buys them, they're subtracted from the inventory. Inventory takes care to manage the product profile. Now, this is a very classic example because this most often happens across various projects that we have CRUD, and then there is various entities, and there are usually it is plus and minus which happens, okay, or there might be something that reads and something that writes. So that kind of things, these core use cases, here data duplication starts, because earlier what used to happen, we used to write to one database and fetch from the same database. The database might be clustered, or you can use it in RAC form. But now what happens is that real application clustering is Oracle's product, so that is RAC. The other ways, what you means it's a different form of clustering you can use, but the database remains same. But with newer paradigms, what happens is that the data is now across databases, across the various entity. The same entity is across various databases, physical database schemas. How are we going to make sure that this data is in sync and there is a single version of truth? So that is the challenge that is there in the Microservice architecture. Okay, with communication. So communication means um, now, which whatever I spoke just now, how we are going to make sure that one microservice is able to communicate with other microservices. Why it's required to maintain data in sync, to allow transactions to happen correctly, just because there is a need to exchange some type of information with each other, okay, or maybe even to collect the health data or to whatever. In under such, I mean, the same thought lines, you can think of any kind of communication that happens in microservices. It may fail, okay, or it might be due to network failure, service unavailability. So how are we going to handle such challenges is one of the it's one of the important, you can say, challenge within the Microsoft architecture. How are we going to handle that? Whether it's going to whether we're going to make sure that we are going to report it through gracefully, okay, or it just fails. And when it fails, what is the way that we can? Do we have some kind of retry mechanisms? Do we have some backup mechanisms? Do we have something called as throttling mechanisms? Okay, what are the ways that we can make sure that um we handle the failure? One is failure detection, then there is failure recovery, and then just making sure there is graceful failure. Okay, so all those things, how we're going to do in the Microsoft architecture is one important thing. The maintenance. Okay, now earlier teams we used to have mostly system administrators, or even if you want to call them DevOps, okay, they used to handle one entire monolith, even if they are on container or cloud, they are one monolith. But now we might have multiple kind of services, and they might be deployed region wise. They might be on containers or not on containers, Docker, Kubernetes, AWS, Azure, whatever the company is using, whatever deployment architecture they follow. So in this circumstances, the there is heavy hit on the pocket, which means more maintenance cost and more resources to maintain. Okay, whether it's hardware, software resource might be there. There might be more engineers required to maintain them. So DevSecOps process need to become more stronger, more complicated, and more cost is involved. So that is the challenge. One of the challenges of adopting microservices. Okay, so when we talk of these points, that is overhead, high skill complexity, redundancy, data duplication, communication, we cover most of the challenges that once we say that I know why I'm moving from mono to microservices, I have good knowledge of microservices. Do you know what are the more like in that decision? Do you know what are the challenges that are involved? So once I say yes, I am sure I know the challenges, then we can say now I have all the information. I have covered all points that are required for me to move to the microservice architecture. Okay. I at the end of this, not this session, but at the end of this exercise for an organization, for an architect, or for a senior engineer, or you can say mostly like architect, the most senior, most resource who make decision organizations around the management. They say that we have the complete, like in front of me, I have the reasons why I'm moving. I have my standardized architecture ready. I have good knowledge of Microsoft architecture. I've certified my architecture. I know the challenges, and I'm acceptable. I accept these challenges, and then I'm making the move to Microservices architecture. Under such circumstances, the chances of failure or the chances of having when you spend such effort, okay, which is not necessarily going to be lots of months or might be few weeks, okay, might be like you can say 6 weeks or 8 weeks or whatever, like along with your other activities it goes on, okay, to say that my organization has spent this much effort and now we are ready. We are going to take our entire like we are going to move the first product and we have a complete roadmap one by one using our reference implementation. We're going to, for like I'm talking about enterprise, we're going to move one by one our products across to the Microsoft infrastructure. So that's the idea. So when we spend such efforts, such thought process in understanding things, um, that is when the kind of development efforts becomes more predictable, the failure chances reduce. So that's the way we can say that we are going to move from monolith to microservices in a safe manner. Okay, which means that there is going to be less you can say blood spilled. What means is that because we are prepared so well, there is going to be very less chance of failure and very possibly we may face small issues, but we are so equipped and so knowledgeable, skilled as team in microservices that we'll be ready to handle it upfront. If you're not handled upfront, we'll be ready to handle it because we have the knowledge with us. So that with that I can say that I have covered all the points that we had set out for this session. Okay, and I have got because there is one more session after this XK session. Maybe few of you are attending that. I would just give another three. I have another 3 minutes. Okay, by 4:59 we'll end the session. If you guys want to kind of share something, okay, in terms of your Microsoft experience, in terms of kind of queries or like anything that you think is useful for this larger set of group here, please go ahead and share that in this. We have 3 minutes with us. Okay, so guys, if there is nothing today, I see there is less participation. I'm not sure what is the reason, but usually there is be at least two, three, four questions. People had something to contribute. Today, I don't see any response from the team. Okay, so whatever it is, this is about my book, and then the next thing is that I would request you to, if you like to follow Java J2E, microservices, and Monolithic or whatever in terms of software development, please go ahead and subscribe to my blog. You just have to scan this QR. Okay, I'll send this PPT to all of you. This recording will also be available. Okay, anytime you have any questions, like out of your mind, you have some thoughts, you can ping me directly as well. Okay, on Teams, and I'll reply to you. Yeah, so I think that is already. Thanks
Sumit,
for participating.
there are some people who are raising their hands. I think you might want to look at that.
Sorry, because I have apologized.
I saw some raising their hands.
Yes, I also
Just
see
check
that. Yeah,
that.
one moment. Sorry. Just one moment. Yes, Mohit Singh is there here. Mohit, would you like to add something? Please go ahead.
Yeah, Sumit, I was asking is there any case you have encountered while developing microservice architecture, part of your project or microservices are written in different language, some in Java, some in Python, and something like that?
I myself have not worked on anything like that, but I know of projects where there are teams. They had parts of it on Java J2E, and I think the some service around C sharp, as far as I remember. And they were using Microsoft architecture, and that is what I know because they were all deployed on the AWS environment, and I know that from some interaction I had with some of the team. But me myself, I've worked on only hardcore Java J2E stuff, and there are legacy Java J2E project, and we had to take that Java J2E and put into newer Java J2E Microsoft architecture. That's the kind of thing is what I have been involved myself. But I know of through interactions that there are teams who are involved across technologies in the Microservice projects.
Sumit, are there any enablers to move from monolithic to microservices, especially from a designing perspective? For
Mhm.
example, extracting the object model from monolithic
Uh,
architecture and being able to derive
Uh,
that what kind of microservices would be the apt
yeah.
ones?
Automated way, that's a good question actually. Okay, a very good question. Is there some kind of a enable, like, I mean, it's a very good question, because to any architect mind it will come that if I can take the object model and answer few, possibly answer the questions, or kind of point my code base, can somebody give me a recommendation? I have not come across such thing, but I'm sure there'll be some. I have not come across such thing. That's the answer to your question. But there might be something there that is there in the market. Okay, it might be open source. It might be somebody's single person's effort to, because this readiness certificate which I told you, right? It's actually a site called Microservices.io. There's very few people working on that site, and they are the ones who build this readiness certificate kind of thing. So that is same way, I think somebody would have put in some effort somewhere in the world to say that yes, this is the way you can say that this qualifies. From my understanding, this qualifies to be a microservice. It's possible. There might be something that exists like that.
So I think we have a number of people in the group. The question is for everyone as well.
Yeah, yeah. Please go ahead, guys.
And
Yeah,
if
please, please. Yes.
and if no one is sort of aware, then I think it would be a good idea for someone to take that initiative and explore. And
Sure, sure,
that could
sure,
be a good value add for us.
sure, Manu. I think I'll have the answer offline in this chat sometime later, or I will just maybe in the future sessions. I'll try to answer this in the future sessions.
Sure, but others also, please, if anyone wants to take that initiative and explore, then I think on this channel itself you can sort of reply, and it will benefit everyone.
Yes, guys. Please note Manu's point. Please try to add value to the session, all of you. Deepak, please go ahead.
Hi, Sumit.
Hi.
So, when we actually divide the system into chunks and modules, we increase the chance of violating drive principle. Most of
Violating
the
the
time, we see. Sumit, am I audible?
violating. Yes, but I'm not. It's very meek. Violating which principle?
Drive principle.
Yeah, it's possible. That's what I told
Drive.
you. It happens. It
Okay.
happens many times, many times.
Yeah.
The
So my
dry.
question is,
Mhm.
how we can balance this? Means when we dividing, we also be able to safeguard the drive principle as well.
See, that's what I told you. Like, there is no. I cannot say there is any automated way. Okay, there is only one thing: the architect. Okay, or the person who's like chief technical responsible, including the discipline of every developer in the team. We have to make sure that the common components, the common objects. Okay, common objects you might have to repeat. Okay, but the common components, the common utilities, they are not repeated. Like, let's say I want to build some encryption utility that has to stay in a library and should be made available to everybody. Now, what I've observed most of the times, that every development pod, like every development mini development team, they start building their own because they don't have that much synergy of interaction. There is nobody to maintain the discipline. So that is the kind of thing where I'm telling that don't repeat yourself is violated many a times. Okay, in terms of code duplication. So that thing is what has to be enforced via discipline only. That's the kind of answer I have. Yeah, Satish.
Yeah, yeah.
Guys who want
So
to people
just
who
I
want
have
to leave, guys, people who want to leave the next case for next year's SKE, please leave. Okay, because time has gone ahead, and in a way the session has ended. Only that we'll let Satish will answer Satish's question. Satish, please go ahead.
yeah I don't have a question, but I have an answer for Deepak. The base question,
Please, please,
like
please, please, please,
Deepak, we
please.
have a hexagon pattern. Okay, so the hexagon pattern is mostly used for avoiding the dry principles. Okay, and also hexagonal pattern, Sumit.
The hexagon pattern.
Yeah, hexagonal design pattern, which is mostly used in Go. Okay,
Okay,
so that should be used for avoid the dry.
okay. Even I'm not sure of that. Guys, please note that hexagonal pattern. And Satish, if you can send us some link also on this, will be very great. Okay, on the just paste it
Yeah,
on the
sure, sure. I
on
will
the
do. I
chat.
will do. I have a workable code in my GitHub repo, and I will share.
Thank you, guys.
And
Thank
also,
you.
Sumit, I have another doubt. Like,
Yeah.
so separating the services does matters means, so we can go with the service oriented architecture, right?
Yeah. Okay. Yeah. Yeah. So
So what is the major difference between the microservice architecture and the SOA?
yes. So what happens is that, see, SOA is a coarse grained. So before the advent of microservices, in between the years where people used to use SOA. Even today, the people use SOA, okay, and they start mixing SOA. Like SOA is like a misnomer nowadays. Microservices is the way ahead, but SOA still exists. So idea was that coarse grain. Coarse grain means like earlier we used to think of monolithic architecture. Then we used to say that there are many products in my company. There is a .NET product, there's a legacy mainframe, and there's a new Java J2 system. How we can make sure that they will talk to each other? So we used to bring in the enterprise service bus, and then we used to say that we have the SOA architecture. With microservices, these things, it's not that simply it's changed to REST microservices. The entire standardized architecture has changed now. We have a way to say that how we are going to implement the API gateway, the circuit breaker, service discovery mechanisms. Also, with the advent of cloud and containers, the way of deployment has changed. So all of these together, the microservice becomes, in terms of use cases, very fine grained, and in terms of architecture, more standardized in a different way, in a way separate from the SOA. But even then, now both are mixed, and we can use the word microservices in terms of everything that is for fine grained architecture. We use microservice architecture. That is the idea.
Okay. Smith, even I worked on the same architecture, right? So that's why I'm asking.
Okay.
I worked on my mingled like SOA and microservices patterns. Some applications uses kind of a buses for the intercommunication, and something uses the REST calls.
All right. Okay. This is a project for which customer?
No, my in the sense not in my current organization, in my previous organization.
Okay. Great, Satish. Great. So this is what I want all of you guys to at least share experiences, and if possible, that you can really reveal the name of your customer if it's in Sabia, and just to share that, and just because this is what is would be going on across Sabia and in your previous organization as well. You would have a lot of such stories or such experience to share where you face such issues like face such issues in movement. You decide against microservices, that might be some chances, or you kind of went ahead with success story of microservices. All that I would request that people participate in the future sessions and please share them. Okay, participate in the session. I guess that with that, I think we can end this session. We have overshot the time. Thanks everybody for participating. Thank you very much. Have a good evening.
Thank you, Smith.
Thank you, Sumit.
Thanks.
Thank you.